How to select the best framing system for retail construction based on structural properties. Welcome to Building Knowledge 101. In this video, we will cover how to choose the best framing system for retail construction by considering critical elements such as wind load and dead load. So let's talk about some structural properties here. In selecting the correct frame for each project, the first thing we need to look at is the structural requirements of the verticals. We need to get the correct wind load in terms of PSF, or pounds per square foot, and evaluate how your frames will hold up to your design intent and the project wind loads. And let's go through a couple of examples here and show you what the systems are capable of. The first one here is a 2 by 4.5 inch thermally broken storefront. For this exercise, let's assume the verticals are 5 foot on center and the wind load is 25 PSF. Given those conditions, this system can work up to an 8 foot tall elevation. Here's a 2 by 6 inch thermally broken storefront system. The verticals are the same, 5 foot on center, and the wind load is 25 PSF. So this system can reach up to 6 foot 10 inches tall. Now looking at a curtain wall option, here's a 2.5 inch sightline curtain wall system. If we look at a 6 inch configuration, verticals, same spacing and wind load, we can run that vertical 12 foot tall. We also have the option of moving to a 7.5 inch thermally broken curtain wall system. Looking at that, we can run it to 14 foot 6. So you can see as we move across from left to right, we're getting stronger. The structural capacity of the systems is increasing. Now, this is not your only options. Within each of these different systems, you do have other options for heavier wall sections or for adding internal steel to increase the structural capability. I'm just looking at kind of your standard examples here. But like with a 4.5 inch system, there are options for heavier wall sections that will increase the ability of the system to go up to 10 foot, maybe 10 foot 6. So here's an example how we'd evaluate a specific project design intent. Here's a curtain wall elevation. So to start with, let's assume that we have a midpoint anchor at this point behind the vertical. So our verticals are anchored back to midpoint steel behind that. Our vertical spacing is 5 foot on center, and the elevation now is 20 foot tall, and we have a midpoint anchor at 10 feet. So we want to evaluate, will this 2.5 by 6 inch system work? So here's a chart that shows our different wind load options. Let's say our wind load is 30 PSF. So we're going to be looking at curve B on a wind load chart. So to evaluate this elevation, across the bottom is our mullion spacing in feet. So we're 5 foot on center. So we're going to draw a line starting at 5 foot up to where we meet a line horizontally on the left, showing the height of the elevation. So where these two lines meet needs to be below the curve that represents our wind load. So our wind load is 30 PSF, which is curve B. So we need to be below or to the left of curve B. So you can see here on the chart, we're fine. This system will work out great with a 2.5 by 6 inch system. So here's a typical storefront application. This is an exterior, it's under a cover, but still it's going to be subjected to the wind. So we have to evaluate structurally what the system will hold up to wind load. So our vertical spacing is 4 foot on center, and the height of the verticals is 9 foot. We like to evaluate using a thermally broken storefront system. So here's a chart showing our different wind load options, and we're going to look at 25 PSF, which is going to be curve C on this chart. So we'll do the same thing. We'll look across the bottom here for our vertical spacing, which is 4 foot, trace a line up to the height of the elevation, which is 9 foot. And where those two lines meet is right on curve C, which is 25 PSF. So we're fine here. This meets it. But then notice, if our verticals were any wider, spaced out any further, we wouldn't meet the wind load. Or if our verticals were taller, we wouldn't meet the wind load. So we are right on the wind load for 25 PSF on this elevation. The curves below this represent 30 and 40, and again, we wouldn't meet those either. So we're good to go here. IBC, or International Building Code, contains wind speed maps that indicate areas that are considered high velocity wind zones. These are areas that are prone to damage from hurricanes. If your project is located within a high velocity wind zone area, you will need to utilize a system that has been impact tested for that application. Here's an example of a storefront system and curtain wall system that was designed for this application. Note that the glazing used contains a laminated inner layer. Depending on the test, the glass could be either wet sealed in place or dry glazed. Since these frames are part of the building envelope, the entire system, including entrances, need to be impact tested. The intent of this is to maintain the integrity of the building envelope during a storm and protect the safety of the building occupants. Here's another option that's available for high velocity wind zone areas or flooding potentials. This is a manually installed storm surge threshold. In the event of a storm coming, this threshold can be manually installed to the threshold, giving you 12 pounds of performance against water being blown in from an oncoming storm. So not only do we need to be concerned with wind load, we also need to consider dead load, and this is the weight of the glass. The frames need to be strong enough to support the weight of the insulated glass set into them. On retail applications, we want large lights of glass to allow lots of natural light inside and let people look through and see our display of merchandise on the inside. Now, this is not a problem with large lights of glass sitting on the sill, because on the sill, we're going to put shims underneath the setting blocks supporting the glass to transfer the weight of the glass down to the sill and then to the slab below it. The concern is on intermediate horizontal. So you can see in the picture here, on this large light of glass, we're going to put our setting blocks at quarter points to support the glass properly. And then to prevent the sill from deflecting, we're going to put shims underneath it, transferring the weight down. But our concern now becomes on intermediate horizontals that do not have the option of shimming underneath them for dead load support. We've got to rely on the structural capacity of the horizontal to carry the weight of the glass and not over deflect. If the horizontal deflects more than 1/8 of an inch, we could damage the light of glass below it. So your starting point with setting blocks is always going to be quarter points. So you can see here, we've got quarter points indicated here. We need to evaluate the weight of the glass and will that horizontal support the glass with setting blocks at quarter points, or do we need to move the setting blocks to 6 points or 8 points? So changing the location of the setting block increases the ability of the horizontal to carry more weight. As you move the setting blocks out further, closer to the verticals, you transfer the weight of the glass to the vertical quicker. So there's less unsupported area between the setting blocks. So most manufacturers are going to have wind load charts for every system. They're also going to have dead load charts for every system. So here's some examples of evaluating how much glass weight the system can support. On the left here is a 2 by 4.5 inch storefront system, similar to what we looked at earlier. So let's assume our vertical spacing here is 6 foot, which is pretty wide, but let's say it's 6 foot. So if I evaluate the storefront system with verticals 6 foot apart and my setting blocks at quarter points, I can only carry a light of glass that's 2 foot tall. But if I move my setting blocks out to 8th point, I can now carry a light of glass that's 4 foot tall. The next illustration is a 2 by 6 inch storefront. We're looking at the same vertical spacing of 6 foot. When I start with my setting blocks at quarter points, the light of glass that I can carry is 4.5 foot tall. But if I move my setting blocks out to 8 points, now I can carry a light of glass that's 8 foot tall. Looking at a curtain wall option here, we've got a 2.5 inch sightline curtain wall and a 6 inch vertical. And if I take the 6 inch vertical, same 6 foot spacing, the 6 inch deep system, put my setting blocks at quarter points, I can carry a light of glass that's 8 foot tall. But if we take a look at the 7.5 inch deep system, same vertical spacing, 6 foot on center, setting blocks at quarter points, now I can carry a light of glass that's 12 foot tall. So you can see as you move across this comparison, as we move from left to right, the frames increase in structural strength and can support larger lights of glass, larger and taller elevations. This elevation is a storefront system, but note how the lower light of glass in the system is still fairly large. The upper unit is just as wide, but less than half the height. So you can see on a wide horizontal like that, we have to reduce the height of the light of glass. But the lower light of glass is sitting on the sill, so it's not a problem. So this is a very common strategy to make your lower light of glass quite large because you're not concerned about dead load. It's being transferred down to the sill very easily. Then the lights above that aren't quite as tall. People walking by can still see uninterrupted through this glass to the interior, and people on the interior still have a nice view to the outside without interruptions because the large light of glass is in their viewpoint. Standing up or sitting down, they can see clearly through it. This is the same type strategy in a curtain wall. Notice the lower lights of glass, even though they're displayed elevation, they're quite tall. And then the upper lights of glass above that are not as tall. They're reducing in height, reducing the weight on the horizontals. So the strategy here is to introduce tall lights of glass, big lights of glass, down low where people walking by have a clear, uninterrupted view to the interior, can see the displays, the mannequin, to see all the merchandise on the inside. but then the upper lights of glass that no one's looking directly through aren't quite as tall, reducing the weight of the glass on the horizontals. That is all we have time for in this video. If you'd like to watch more of our 101 video series, subscribe to our YouTube channel, Kawneer Company, Inc.